Sudoku Degenerates, welcome. This is my somewhat belated first puzzle stream this week. And, oh yeah, I should pin links to... Hey, Flinty and Damo. Welcome in. So, the next Fortress Philomeno is region counting arrows. Solver list includes a legend. Well, it includes several legends. So, Fortress Philomeno, I divide the grid into orthogonally connected regions and fill each cell with a number, not necessarily single digit, showing the number of cells in the region to which it belongs. Each region must be either strictly larger than all of its orthogonal neighbors or strictly smaller than all of its orthogonal neighbors. Region counting arrows. Numbers in cells with arrows count the number of unique Philomeno regions in the indicated direction. The arrow does not count the cell itself, but will count other cells in the same region as the arrow. If an arrow sees multiple segments of a region, that region is only counted once. For answer check, just enter the ones digit for any double-digit numbers. Oh, hey, Dorlair. Welcome. So this is either 1 or 2, because it only counts 2 cells. Same here. Hey, Chinstrap. Not much. Just got off work for the day, came home, and got set up for my stream. Okay, and this is 1, 2, or 3. Now, if it's 3, this is 2. So I know these are both... Oh, right. You can never have a pink 2. So they must be both blue, and which means there is a pink in between them. Now, if this joins this, it is 2. Oh, but wait. If this joins this, it's 2. But if this is... These are different... Oh, this could still be 1 if these are both... Oh, but wait. Then this would be 2. That doesn't work. So either way, this is 2. So this is either the other 2 or it's 3. Yeah. Oh. Wait, could the 2 of... No, the 2 couldn't go up here because that would break this. Right. If this is 3, then the 2 goes here, so the 3 goes here. And it doesn't join that or that, so these would both be blue. That makes this pink. If this joins this, it's 2, then these are all pink. Interesting. What about this? Well, there's no way this is 1. In fact, there's no way this is less than this. Could it be the same as this? Could these both be 2s? Oh, if this joins this, then yeah, these could both be 2s. But what if this joins this? Then it's 2. This is at least... Oh, then this is 3. Yeah, it's unique regions. Because, like, if these are both 2, then this is all the pink region. These are 2, and this 2 either takes this or this. But it's still, each of these arrows would only see 2 unique regions. In that case. Yeah. Oh, and this can't be 4. Because then all of these need to be in different regions, which makes this a 1. These can't be. Right. So this is either 2. Oh, I guess I could use uniqueness to show. Well, no, I couldn't use uniqueness because then this could join an arrow. This could still resolve whether this was. Yeah, and I don't want to use uniqueness anyway. This is only 1 through 6. Yeah, full rank. At least large. Oh, nah, sometimes the eye tracking messes up. Although sometimes... Sometimes when, these over wings, it's because I got, like, some... I'm rubbing my eye because I got dust in it or something. Okay, so what... Can this be 2, 2? It'd make this 3. This... Okay, these are all pink. This is blue, so this 3 gets out here. Huh. I can't see anything wrong with any possible way of doing all of this. If this is 1, of course, these are all... Yeah, I can't really see a way of narrowing down anything here. Music's getting a bit loud. Yeah. Well, let me know how that one comes out. Yes, restraint and patience are definitely key. This is 3, it joins that. This is 2, it joins that. So either way, this is always pink. And there's always a border between these. An 8x8 with 6 skyscraper arrows, and it was only a deadly pattern, non-unique in the final 2 cells. Oofda. For column 3. Well... Oh god, this is always 3. It can't join the... Right, it can't be the same as this. Duh. Oh god, okay. This has to get out through here. And I know it takes one of these 2, so this is... And I know these are from 1, 2, so this Okay, this is 3. Oh. That doesn't actually tell me whether this is 1 or 2. Or does it? This is 1. So there's 2 more up here. So if this is 1, these are the same. If this is 2... So I guess either way, this is pink. That... Yeah, I'm already coming up with ideas for impostering people. Okay, so now... This has to go here. If this goes here... Oh wait, if this goes here, then we have these 3 blues, right, okay. Ah.
We must be near the island.
So this is at least 4. Now this... And I know this is exactly 5. Oh, well, wait, this 1, 2...
I'll get you there.
And this is 6. Now, so this cannot join this, otherwise it's a 5, it's a pink 5 next to a 6. So this is blue. Oh, and there's no way for this to be blue as well, because then this 5 could never escape without touching it. So it joins this. This 5 gets out through here. It also takes that. I don't know if it takes that or that. Oh wait, if it takes that, then the 6 becomes too big. So it has to do that. That's blue. That's the 6. So there's borders between each of these. And I also gotta remember that it's unique regions, not regions that tie. Right, okay. A whose pot? What is, Oh, Pal Pot. One, 2, 3, 4, 5, and this must be part of either this region or this region. So this is 5. Ah, and it can't be pink, or else, okay. Neat. Oh, wait. No, this could still join this. So this is 4 or 5, and this can't be either. Okay, lucky I caught that. Because now I know that it's exactly 4. This is at most 4. And at least 2. Wait, there's no way it can be 2. Because, oh wait, this could, no wait, this can't loop around. This has to, okay, I don't think this can be 2. Oh, this is 5 or 6. Oh, hey, Carl. How are you? Okay, good to know that I have not. But if this is 4, this has to be at least 5. Even if this is pink, that's still at least 3. Okay, so... And these cannot join each other. But there's no way this is... Yeah, because if they join each other, this is obviously broken. Right. So, either way... this is pink, that's blue, now this gets up here. Now it either takes that, oh, but if it doesn't, it gets out through here and that's broken, so that... Hey, thanks. And this is what will resolve whether this is 1 or 2. Okay, this is 6 or 7. Oh wait, this is 1. This has to be at least 6, so it gets out through there. Now, there's no way for this to be 1. Because it needs... Because, like... this cannot take all of these, so this does need to get out, making it at least 2. Can I say anything else about it yet? I don't think I can. Not immediately, anyway. This is 4, 5, or 6. And I don't have any... I don't think I can narrow this one down very much at all. Now, if this is 5, it's blue, and this is pink. But if this is 6, then this is blue. I think this could still technically be pink in that case. Oh yeah, it's at least 3. But wait, this is at least 3. So if this is 5, this is pink, but this has to grow here, and then these are both blue, but they're... Or could this be 5? Yeah, I think this could still be 5. It would make this join this, but that's fine. But wait, where does... Where does it get its 5th? This has to be pink, and it has to get out through here. So that's the 5, but then this is 6. Which means there's borders between... Oh no, this would be pink. Oh, that does actually work. Wait. Oh no, that breaks. So I don't think this can be 5, but that is very look-aheady for a 3-star, even in 2026. Oh, if this is not blue... Right, then it joins this. so it's at least 9. That does not work. Okay, so this is blue. If I'm missing something obvious again, or if I'm missing something clever this time. This is at least 3. This does not join this. If this goes here... Okay, say this comes up here. Oh, but wait, this can't be 6. Because any pinks in here join this. I think this is a max of 4, isn't it? Right, so this... Right, that is a much easier way of saying this cannot be 5. Right, and now... Right, and now this can only be 3. Because it can't see another... Right, okay. This has to be blue. This has to be blue. This has to get out through here, has to take at least those, and either this or this. Now this sees 1. Well, basically it sees 2 in here. This is... Oh, well, it's at least 3 and at most 5, but I knew that just from regular... Okay, this be 6 now? Good question. It makes this blue, this pink, oh. But then that's a pink touching a 6. Right. This can't be 6. Okay, if this is 1, the spray, okay. Oh, well, I guess the issue is if these are different, is there any way they don't touch each other or cut off a pig? Yeah, this could be 1, but like even if these are 3 and 4, and one of them takes this, well that's gonna, I don't think I have enough room up here to make these different. So they must be the same, which in turn and the only way they can reach each other is that. So this is 4, so this is 2. Hey, Stu. Ah, okay. 1, 2, 3, 4. Okay, so this is 4. Ah, that's it. So this becomes 7, and for this, 7, 8, 9, 10. Okay. 15. Okay. Thanks for the GGs. I definitely should have gotten this much sooner, but yeah. I do think this was more like 4-star than 3-star, but whatever. It's close enough. Alright. And still pretty fun. Next up, Marty sent this in a while back. Called Slithering Heights. Oh hey, I've read that book. Aha, it's a more Slitherlink. Normal Sudoku rules apply, so every row, column, and 3x3 box Got to put 1 to 9 once each. Draw a loop that travels along cell edges and does not touch itself. Every cell is surrounded by 8 dots. The digit in a gold circle indicates how many of its cells' dots are visited by the loop. So it's the number of edges plus the number of corners, basically. And if 2 digits are joined by a black dot, one is double the other. So one of these must be double the other. Here, here, and here. All right, so this is 2, 4. Now, all of these would be 0 if this is 8, so that is not 8. And this cannot be 2 in that case. Hey, alright. Oh, well. What, hello in Serbia. Now, okay. So I can never put 8 or 9. Well, I definitely can't put 9 in a circle. But I also can't put 8 in a circle unless it's the only circle. So, this is 8 and 9, so that's 8 and that is 4. That's 9, so that's not 4, so that's not 1. Now, this being 1 or 2, it means none of the edges are taken. So, it takes at least one of these corners and possibly both. And this is a max of 5. Same here. And it can't be 2 because the 2 in this box goes in one of these 2 cells. Now the 7 is going to be a cul-de-sac. Oh, and it's in one of these. 6 is also... No 4 on here, so this is either a 1, 2 or a 3, 6. So 4. Obviously, this does not... I can't take all 4 corners, but no edges. And the only other way of making a 4 is taking one edge and another corner. If this is 7, this is either 3 or 5. There's 2 ways of making... is all odd. Oh yeah. Well, I know this corner is odd. Well, I think this could still be even. Yeah, it is. Yeah, 6 could go up here. That would be very forcing in terms of... If this is 6, this is 7. The loop either does this or this. Oh, neat. Oh well, sometimes they I guess there's no fog here, but sometimes the rats were hidden in fog. So I know this is visited at least exactly twice. If this is 1, this is 2, this is 4, so this is an 8-9 pair. Let's see, where... I guess 8 and 9 in this column only go here. Like, I know, can I draw? Is it possible this is 1? If we, let's make this 5. Is it possible this is a 1? No, because then this would be 2. Okay, this can never be a 1. What about this being a 1? If this is 1, that's 2. Yeah, neither of these is a 1. Ah, and this cannot be a 2. So these are in fact a 3-5 pair, so that's not 3, that's not, which means that's not 6. Yeah, 2, it always has 2 corners and nothing else. So if this is 2... If this is 5, this is 7. Oh wait, there's no way for this to be a 2. Because it forces this, or wait, no. It forces this, but then this 4 is broken. Because it can't take one more corner. So that's not 1. This is 1, 6, or 7, and I don't think this can be 6. Yeah, this cannot be 6. This is 1 or 7. So there's a 6 up here. And if it's here, there's no way this is 1. So this is 6. So, okay, there's a couple different ways of making 6. I could do it like that, but that breaks this 4. Because they'd have to go like that. Now if I do it like this, that works. Making that 7 and that 1. So the other option is for this to take that, that, and that, or that and that. But since this can't be 3 or 5, yeah, the only option there, yeah, okay, so this is always 7. And, okay, that makes this a 3. Alright, so this becomes a 7. And also... Okay, if this goes like this, yeah, that breaks down here. So this does that. Now I don't actually know whether this goes this way or this way, or whether... Yeah, there's a few different ways. I think this is always part of the loop. Oh yeah. Ah, now this can't go up. Oh no, wait, it can. If it closes there and this does that, yeah, that's fine. Okay, so, but this is at least a 5, and it's not 5 or 7, so it is 6. So, this is not part of the loop, but this becomes part of it, and that leaves 7 here. Ah, now this cannot go here, or this would be at least 6, so this becomes 4. Oh, and none of these are taken either. Oh yeah, 3 in box 4 goes here, and these are a 1-2 pair, so this cannot take that or that, it has to do that. And so this does not go that way, this does go up here. Which means this 4, the only way that works is if it does this. And there's no other way to get to any of these. So this becomes a 1. Simply because this is the only way it can be touched. Okay. Oh, this has to do that, and this has to do that. Ah, no 4 or 6 on here, so this is only a 1-2 pair. Now, there's no way for this to be 6, so that can't be 3. This is only from 1, 3, 5. Oh, I should also 5, 6, 9. This is 5 or 6. So this is always gonna... This always ends up down there and goes that way. No matter if this does as well. Has an edge at top counts by 1. Right has 2. Oh. Interesting. Oh, this is 5 or 9. I know one of these is a 6. Now, if it goes through here, that's a 5. If it goes down here, this can still be a 6. Okay. Wait. Oh, this is at most 3, and it's not exactly 3. So this is 1 or 2. Right, and this... I know this is at least 3, and it's not 3, 4, 6, or 7. This is 5. Right. So the only way 6 works is if it does this. So this is not 1, this is 3 or 5. This is at least 6, and it's not 6, so it is 7. And this cannot be right. Okay. So, and right. Okay, so this. Right. So this is 1. Oh, this is 5 now, which does that. All right. 2, making this an 8-9 pair. So this is at most 5, and it's not 3 or 5. But it's at least 2. This is 2 or 4. Oh, this is at least 4. And it's not 5 or 7, so it's 4 or 6, but it can't be 6. Because it just can't take enough, so it must be 4. This is 6 or 7, and it is not 6, so it is 7. So this is 2. Oh, this cannot go down because the 2 is done. So this is basically 3, 4, or 5. Oh, and this can't be 7. I think if this is 4, we're in trouble, because the only way to make that work is if it does that, and then one of these corners is taken, but the only one that does that, that makes this at least 6. Oh, hey, pause! So I don't think this can be 4. Well, wait. Maybe it might be easier just to see. Hey, pause. How's married life treating ya? There's a 1 in here. It's obviously not. This is at least 3. Oh yeah, this is a 4-5 pair. That helps. Oh, welcome back, Isaiah. Yeah, it's easier to see now. I think the only way this works is to do that. Ah, and now I can't close the loop prematurely. Oh yeah, the weather is... Okay, this is at least 5. Oh, it sees 5 and 6, so it is in fact 7. So what we're left with is 6, 8, and 9. That's 8 and 9. And that's 6, 8. Oh, that's 6, 8. So that's 9. So, oh, 7 in this box only goes here, making this a 1-8 pair. So this becomes 1, 3, and... Oh, 1, 2, and 3. No, not 1, 2, and 3. 1, 3, and 6. This is 4 and 9. 2, 5, 8. And this being... Alright, what about... This is 3, 8, or 9. Okay, what about this? This is 2, 3, 4, 5. This is, okay, this is just 4. And I'd hoped there would be at least one of these in here. Okay, that is 6 or 7, and it can't be 7, so that's 6. Yeah, the all corners 4. You gotta have at least one of those in a more Slitherlink. This is at least 3, and it's not 5, 6, or 7. This is 3 or 4, and either way... Oh! Well, it can't do that, because it'd be at least 5. It has to do that, and... Right, it has to just be 3, because you can't take a corner there. What's left here is 1, 2, and 5. What's left in this box is 1, 2, 3, and 9. Oh, 2 in this box only goes here. 3, 9. Oh, that's 9. And this is a 1, 3 pair. This is a 4, 8 pair. This is... Oh, this is 6 or 9. Nice. And it is not 9, so it is in fact 6. Alright, that's a 7, 9 pair. This is 3 or 8. This is 5 or 9. If these join each other, it does this. But if these don't join each other, it does this. And I think either way, this is always part of the loop. This next part is what took you a week to set. Oh boy. Yeah, cause like if these don't, yeah. So I think no matter what we do here, this is always part of it. Oh, 3, 7, 8, 9. This is only 3 or 7. 2, 5, 6, 9. This is 2, 5, or 6. Oh, right, I can't close it. Right. These have to do that. Okay. Now, this could still theoretically be 7. If it goes like this, and this gets out through here. Then if this is a 3, oh, it has to get up through here and then... I think either way, this has to go up and this... This always does this? Oh, yeah. This is forced regardless of what... Wait. Yeah, wait, this can never be 6 now. Now that I have this... Yeah. It has to be 1 and it does that. Okay, well, my way of spotting all this down here was... way cooler, even if probably not necessary. This is 4 or 5. Oh, 6 in this box only goes here. These join. Oh, I think if these join, this is broken. Because the only way to make 5 work then is by doing that, which breaks all around for a gazillion reasons. Okay, so this does not... Now if... Right, this cannot get out through... This has to link up to this. But if this takes this... Oh, that also breaks down here. So this does do that. Oh, but now I can't make this 5 unless I make both of these 5. So this is just 2. And this becomes 4. Stop that. Okay. This does that, and... Okay, the path is done. and 3. Okay. Thanks for the GGs. Oh, GRV. Ooh, yeah, 159 and Dutch flatmates. Yeah, I'll give that a try. Might not have time for it today, but probably on Monday. Yeah, it is sometimes hard to have both of your constraints resolve at the same time. All right. Oh, which one was that? Let me... Oh, this, right, yeah. I could have sworn I'd added that to the queue. Alright, I'll try this now. Excellent distraction avoidance and so... Yeah, I do tend to get kind of in the zone. Means I don't... Okay. So... Oh yeah, hey Vic. Welcome. So I place the digits 1 to 6 so they don't repeat in any row, column, or 2x3 box of the main puzzle. Greatest line. On each line there is exactly one number whose value is greater than the sum of any other two numbers on that rank. The values on columns and rows read in both directions make a total of 24 numbers of 6 digits. Clues outside the grid show the rank for the indicated row or column along those 24 numbers, where the lowest is 1 and the highest is 24. One or more equal numbers are considered to be at rank n when there are n-1 numbers of strictly lower rank, meaning ties go to the lower rank. For example, we say there are 3 numbers in rank 20 when there are 19 numbers of lower rank, and the next rank will be 23. 19, 20, 20, 20, 23. Okay. So, I guess starting here, the ones take ranks 1 through 4. Twos take ranks 5 through 8. That is the same as in 5s. Well, same as in 5x5 rank ups, where the 5s take ranks 17 through 20. So basically, these must have... Okay. Suppose these are 1, 2, 3, 4, 6. Then the minimum on the 4 is 13. And the minimum on the 3 is 9. That's 22. That's 2 degrees of freedom. But that doesn't necessarily mean Yeah, I think this does still have to be 1, 2, 3, 4, 6, right? And same here. With these being 5s. That feels like the sort of, because, like, okay. What if it's 1, 2, 3, 5, 6? Well, it can't be 1, 2, 3, 4, 5, because 4 plus 3, yeah, 13 plus 9 is still more than 20. 5, 6, 17 plus 9 is still more than 24. Yeah, okay. So these are 5. And the ranks on the 6s must be at least 22. So what do we got in here? We okay, so we can't have a 6. These are from 1, 2, 3, and I know there's a 1 in here. If this is 1... Wait, this can't be 1. Oh, it could be 1 if these are both 2. I've also got to be careful not to make the rank on the 2 too high. Oh, yeah. Yeah, the rank on the 3... Rank on the 2 and... oh, no, well... No, the rank on the 2 can be high along here, because it's still always going to be lower than the rank on the 3. So it's just, I can't make the rank on the 3 too high, or the rank on the 4 too high. Right, and green cannot be 3. There's a 5 in here and a 5 in here. So, what else do I know about the configuration here? I know there's exactly 2 degrees of... Wait. 13 plus 9 is 22. Oh no, there's only 1 degree of freedom. Because the 6 has to be at least 23. Right. Okay, there's only 1 degree of freedom. And is it used up by the fact that... Oh, and the 6... Right, and there has to be at least one of these 2 lines where the rank on the corresponding 6 is exactly 23, because even if they're tied, they have to be 23 and 23. There's no 24 in that case. You can't tie for 24. So, whichever of these, I suppose, like, if this is a 6, this can't be a 6. Oh, well, it could. Okay. Let's say this is the one where the 6 rank is 23. I must make sure in that case that the 4 rank is exactly 13 and the 3 rank is exactly 9. And even if the 6 rank is 24 on the other line, I still have only 1 degree of freedom. So there must be a tie for either rank 9 or rank 13 or both. Because otherwise, there's a tie for either rank 9 or rank 13. What? Or both. What does that actually look like? It can't be here. Or here. So if they're both tied, then these are 3s and these are 4s, is what I'm seeing, is what kind of has to be the case. But wait, there can't be ties for the lowest rank of a... Oh yeah, there can. Right, it's just there can't be ties for the highest rank of a thing, right? Okay, so... So basically, I know these are not a 3-4 pair. So there's a 2 or a 6 down here. Now, if they're right, tied ranks cannot begin with this down here, with either of these digits, because we need a repeat in the box. Either these would repeat, or these would repeat, or else they wouldn't be tied. So what does that mean for what is 9? It's like, is there a reason these cannot be tied? Makes this. Is there a reason these both have to be tied? Or is there a reason they can't both be tied? If these are both tied, hang on. Oh. No, if these are both tied, then I can't put green in this column. Right, okay, so they can't both be tied. Oh, and in fact, wait, if these are tied, then I can't put green in this row or this column. So it must in fact be these that are tied. And I'll pencil mark a 9 out here. Okay, so this... I will... Right, so... So, okay, there's no way to put 4 on here. Oh yeah, 1 in box 5. So that's 4. Oh, these are a 1-3 pair. Right, and one of these... Oh, this is a 3-5 pair. So these have to be the 2 lowest. If this is 6, this means... Oh, that breaks the 4 in here, in this column. Because the 4 in this column would also have to go next to a 6, so this is 2. Right, and now I know that this is lower than this. So whichever of these is a 6... This cannot be 6. Because the 6 in this rank has to be lower than the 6 in this rank. Or equal. So this is 6. Yes. So, right, so this is lower than this. So this is 3. This is 3, 6, and 2, 4. Oh. No, Pepe the King Prawn is a different Muppet. The one who goes, me, me, me. That's Beaker. Alright, so the 6 goes next to a 3 up here. And then... Oh yeah, what about... Oh, wait. Another 4-2. This has to be the second lowest 4, so another 4-2 up here. Right, this is 2, this is 4. Six, 3, 2, 6. 3, 5, 1, 2, 4. Okay, so the 6 always works up here. Okay. What about 3, 1, 2? Oh wait, 3, 1, 2, 4. Right, this cannot be. Okay, this has to be 1. Okay. So now, right. Okay. Nice. Very tricky, but yeah. I do like rank up in small puzzles. Hey, thanks for the GGs. Understandable. Yeah. Alright. I need to... Oh, this was in the queue. Okay. So, I need to refill my water, but after that... I will try film at yin yang. Alright, so let me Okay, I will be right back. Alright. Welcome back. So, it is a fill mat yin-yang, where I divide the entire grid into 1 by n or n by 1 regions where n is from 1 to 4. Two regions of the same size cannot share an edge. Region borders cannot form any four-way intersections. That is fill mat. And yin-yang. I shade some cells in the grid so that all shaded cells are connected orthogonally and all unshaded cells are connected orthogonally, and no 2 by 2 region can be entirely shaded or entirely unshaded. The white circle marks an unshaded cell. A number in a cell counts the number of shaded cells in the 3 by 3 area it is the center of, including itself, added to the size of its region. A question mark represents any number, but X refers to the same number every time it appears. Any region can contain at most one of these clues. I guess that explains what the question marks are for. Okay, so... Oh, hey, Michigan Josh. Welcome. So, this 3... Well, there must be at least one shaded cell somewhere in here. If there's exactly one, it's here. So this is at most 1 by 2. This 4, oh. Well, that's in a corner, so it's less... Ah. There must be at least 2 here. This is at most 1 by 2. Okay, maybe start from the other end. What's the hot 11? Oh. Well, you can have at most 7 shaded cells in a 3 by 3. Yeah. I think that was where I saw this. Okay, this 11, it must be part of a 1 by 4 region, and there must be 7 shaded cells. Right, and... Okay. The unshaded cells are either here... or here. And either way... the outer edge of the grid is entirely shaded. Right, okay. Ooh, you picked this fork of Penpa with way better... Oh. And I know which way the 1 by 4 goes. I don't know its exact location, but I know it doesn't take this. Oh? How? What other way can this work? Oh. Right, it could go like this. Okay, I do know all of these are shaded. And I do know this. And I also know these are all shaded down here. Now, does something break if all of these are shaded? Now, wait a minute. I can't make both of these shaded. Oh, right. This can't be shaded. But I also can't make both of these shaded, or the 3 has to be part of a 1/0 region. So I know that the other... Right. Okay, so that... Okay. Oh, and this is also unshaded. And this is a 1/1. Oh, I also know this goes down at least one more. I don't know... This is a 1/2, so it either takes that or that. So there is... But here, this could be shaded. So now what? Oh, wait. Right. Film mat regions can't make any 4x4 things, so there. And this either has to take that or that. So this is either 1 or 3. And I suppose if it's 1, this must be at least 2. So either way, that is never a border. This has to take that or that, so it can't be a 1 by 1. So there is at most 2 shaded cells, and there have to be 2. Oh wait, no, I could... It's either this or this that's shaded. Either way, all of these are unshaded. And... Right, to avoid 2 by 2s, these all have to be shaded. Oh, wait, this cannot be... This has to be a 1 by 3 now. Oh, and it can't go that way. So it must take at least these 2. Oh, and it can't take that either. Okay, so 1 by 3. So this is not... The shading here has to get out through there. Ah, now this can't have checkerboard. Okay, so right. Oh, and this cannot be 3 or 4, so it must be 2. So this is not 2 or 3, so this is 1 or 4, so it is in fact 4. This is 1 by 4. But it can't join both of these, so it takes at least one more this way. Oh, and since I know this is part of a 1 by 4, it has to join that. How about I do this in an easier color to see, and then at the end I can just go over it all in green. Or actually, wait, settings, any color can match green line edge in a solution. There. Now this could be... Ah, if this isn't this, it is 1. So this... Ah! Oh, that's forced. Oh, and the... Oh no, I still don't know about this. So this is at least 3. Oh, and it can't be 2 or 4, so it's exactly 3. Oh, and there must be 6 shaded cells. How do I put 5 more? Well, I could do that, but that violates checkerboard. I think, wait, is this the only way it works? I think it is. Yeah, because there must be one in here, right? And if it's here, yeah. Okay. Okay, so this has to get out through here. Wait. I think... There's no way this takes this, right? Oh, no, wait. Yeah, it can. In fact, this has to be a 3. It either takes that or those. Also, this is at most 2. A 1 by 2. This has to take either that or that. Otherwise, there's a 4-way border here. Oh, and this can't be a 1 by 1 because it has to take either that or that to avoid... Okay, so there's a... Right, and it also means that all of these are unshaded. So I know this is exactly 2. And then... So what... This is not 2 or 3, so this is 1 or 4. If this is 1, this is either 2 or 4. Now, oh, if this isn't 1, this is 4. So it takes this and means there's exactly 2 shadeds in this. Alright, bye, door layer. Thanks for dropping by. Wait. If this closes here, this breaks. Because this can't be 2, because it touches 2. Can't be 3, and it can't be 4 because there's no room. So, in fact, this is forced. And then... oh. Alright, yeah. So this can't be 1, 2, or 3. It could be 4. Oh, except it can't be 4, because that would be... okay, so this is 1. So this... oh, it can't be 1, 2, or 4, so it must be 3. And this is 2. Alright, so... this can't be 4, so it must be 1. So there's 5 shadeds in here. And this is not 1 or 2. Oh, there's only room for 3. Ah, this must take this. It can't be 1 or 3. Oh, there is room for 4. This is 2 or 4. If this closes here, this... oh, that does work. Okay. So, how do I have exactly 5 shaded cells in this, especially without... okay, if this is green... oh no, that does work. Oh wait, no. Here, now that these are green, I know that this, the shading must go like this. To avoid 2x2s. this takes this, it also takes those two. But if this doesn't take this does take that. And it can't be one... Oh. Well, I guess either way, there's never a border here. And I've also got to keep track of these X's. R94 can't go down. Correct. Wait a minute. Oh. Wait, is that actually correct? If this goes down, these are both closed up. Yeah. So this does not. Now, I don't think it's actually necessarily true that this is... Right, I think I was mistaken in Xing this. This could still be 2 if this is 4. And this is something else, right? Okay. This must take either this or all of these. Wait. If this... Oh, then we have a 2 touching a 2. So this cannot join. This cannot close. So this is either a 1 or a 2. That doesn't actually resolve this 5. So we know that X is 4 plus either 4 or 5, so it's 8 or 9. Yeah, I should probably... Now, if this goes down... Oh, it could work if it's like that. Oh. This takes that, and it doesn't take that. So this is 2 or 3. Oh, it touches a 2. So it must be a 3. And now... Right. There. Wait. Something's gone wrong. Oh. There. Oh, the yin-yang connectivity. It has to get out through here. Which makes that... Alright, so... I'd say 4 stars. Either very low 5 or maybe on the high end of 4, but... Oh, hey, Bells! Welcome! Alright. Oh, what about this? I know... Most to 1/3. Okay. This is either a 1 or a 2. This is either a 1 or a 4. If this is... If this is a 4, there's 2 shadeds here. This isn't... If this takes this, it is a 4. If this takes this, then this is a 1, and this is a 2 or a 4. So what... Oh, what kind of article? So how did... Oh, no. No, there is... Ooh. Oh yeah, if this goes up... Oh, if this goes here, then this... Oh yeah, it would have to be a 1. So either way, there's a border here. Right, and if this... Right, and here. Right, okay, and... Here we get... Everyone thinks they broke the puzzle. For a moment I thought I had too, but no, I realized eventually what... Okay, so... No four-way... Oh yeah! Yeah! Nine... Oh. Ooh. So this can't be 2 or 4. It's either 1 or 3. Either way, there's a border there. This is not 3 or 4. It's either 1 or 2. This is 1 or 4. Either way, it does not take that, so this becomes 3. Exactly. Yes, great minds think alike. And... Okay, so this can't be... Okay, so this can still be 1 or 2. If it's 1, this is 2 or 4. Ah, but if this is 4, that breaks here. That's, but that all depends on this being 1, so that... Okay, so this is not part of a 3. And it is also not part of a 1 by 2. Sorry, 1 by 4. Because there can't be exactly 2 shaded cells in this 8 by 3 without either creating a checkerboard or breaking yin yang some other way. So this is either a 1 or a 2. Oh, and if it's 2, it can't go that way because that would make a 4 by 4. So there's always a border there. Um... If this is a 2, then this is 1. That'd be very forcing, but wait. Okay. This cannot be 4. Because that breaks up here. So I don't think... This is always a 2. And it can't be 1 because that creates a 4-way junction here. So this is always part of a 2. So this is, in fact, 1. So there's 5 shadeds in here. There's one of them. If this closes, there's a border there. There's always a border here, for what that's worth. This is either 1 or 4. If it's 1, that takes that. Comes either 2 or 4. And then... If this goes up, it's 4. So I can't take this. If this goes up, it takes all of these. And then... Oh. No. Well... There's also the fact this is either 1 or 2. If this is 2, this is 4. This is 2. Oh, if this is 2, then this is 4. There's also these here. Okay. If this is 4, if this closes, and if this doesn't close, that looks far less forcing, so it's probably that. Sure, I could use a nudge at this point. So where is... What happens if what's a 2-cell region? This? Then this is 4. This has to join this. So it's... This is 1 or 3. 1 or 2. This is also 1 or 2. Above it, okay. So this is... If I do this, then it's 4. What happens if I do this? Then it's 3 or 4. Why not? Doesn't touch any 4s. Oh. Oh, okay. Right, okay. So... Okay, now it's a 5-star. But, well, it can't take this, so it must take at least one other up here. And now, if this closes, yeah, okay. So we are forced to do that. This must be at least 3. But it can't be 4, or that breaks... Oh, wait. No. No, that does work. Oh, but it can't be 4 because it touches a 4. So it must be exactly 3. Now I could do another 2-1 thing in here. Okay. Oh, hey, Q. Oh yeah, it touches 2 and 3. So this becomes a 2. This becomes 1 or 4. If it's a 1, this 6 is part of a 2. Oh, that would be very forcing indeed. Yeah, I kind of want that to be the case, just because... Oh, wait, no. No, if this 6 is part of a 2, I can't have 4 shadeds in here without breaking the yin-yang, because this needs to get out. So, in fact, this is part of a 4. So there's 2 shadeds in here. So as it is theoretically still possible for this to open. Okay. Wait. Oh, right, this is either 1 or 4, and it can't be 1. And it can't be 4 because it would touch a 4. So it is 1. This is 2 or 4. And this is 1 or 2. Oh, wait, this. Okay. This touches 1, 3, and 4, so it's a 2. And makes this a 1. This is not 1, 2, or 3, so it is 4. And we are once more in a... Well, this must be a 1. And, oh, I suppose it's this hybrid clue that'll resolve whether this is 1 or 2. Okay. This is 2 or 3. I think this... I think if this takes this way, the fill mat breaks. Because it has to be a 2, but now this... Yeah, now this has to be a 1, and now this can't be anything. So I think there's always a border there, which means there's no border there. Now if this does this, this does that. And then... okay. This cannot be a 4. Could be a 1. Could be... This is either 1 or 2. This is at least 2 less than this region, so I need at least 2 more shaded cells than up here. If this is a 1, I will need 7 shaded cells. Oh, and these would have to be... Oh, wait. No, if this is a 1, I need 7 shaded cells, and that breaks here. Because it cuts off this. So this is a 2. And in fact, this is... unshaded, because I can't have 7 shaded cells up here. And I need at least 6. I need at least 6. And I can't shade all of these. I'm looking for something like, does that mean... Oh, no, it doesn't. It doesn't... It resolves this. I know that x is equal to 8. So this is 3. It is not... Huh, I wonder why it didn't go through. I know Rattata's in there. Oh, I think there's two T's in between the second and third A. Let me look that up. Oh no, between the first and second A. There you go. Then there's... Okay, I still need... Oh, no worries. So, how does... Oh, I guess in that case I could never resolve this. Okay. So, how do I get 6 in here without cutting off this? There's several different ways. Can I say for sure that any individual cell is shaded? I don't think I can. What about... If this is unshaded, then so is this. There's so many... This is either 1 or 3. Either way, there's a border there. If this is 1, this is either 2 or 3. It's 2 or 3. If it's 3... Oh, okay. I can't really... Have I been... I feel like I'm missing something a bit more obvious about... I know this is 3. It either takes that... If this is 3, it takes that. This is 2. Oh, that makes this a 2. Oh, this has to be a 1. Oh, and that breaks in here. Wait, no, it doesn't. That's fine. Dang it. Okay, So I know this is a 3. I might need another nudge, because I don't... Yeah, just as I was... Okay, so there's 3 shadeds in here. Oh. Oh, yeah. This gets out through here. Okay, now... If this is shaded, we run into uniqueness problems with this cell. But I don't want to use uniqueness yet. And then... I know this is at least 2. Okay. If this... If this is... Maybe I will use that uniqueness deduction, because this being unshaded is very forcing down here. Or, sure, I'll take a better nudge. I mean, I can see quite a lot of the solution just from that one uniqueness deduction up here. Four. Oh wait, 3. The top X, there's exactly 3. Oh! What does that? So in fact, I know this must be at least 3. So it takes that. Now, if this takes this... Oh, that breaks. So that is closed off. So this is not 1, 2, or 3. This is 4. So this is 3. Okay, so this is not 3 or 4, it's 1 or 2. Oh, but this takes this. Oh, okay, so that's 1. So that's 3. And now we just have this 4 to, oh, this, right. What? Oh dear. Well, let me... No checkerboard, okay, This is not 2 or 4, so it's 1 or 3, but if it's 3... I don't know. Okay, that means this is part of a 3-cell region. But... So yeah, this does have to be... Wait, that doesn't work. Something... Oh. Wait, no, that doesn't work either. Sorry, this can't be good. This has to be broken. Because the 6 must be part of a 3-cell region, right? But it touches this, which now cannot... these have to be part of the same region, and it can't be 2, 3, or 4. Wait, oh. How did I place this? Why did I shade this? I guess I can do that just by that. Then by that, it's way harder to see now, unfortunately. Yeah. So this is 3. That's still... Oh, no, wait, no. This... No, this could be 3 or 4. This is 2. This is 4, so this has to be 3, so this can't be 3, so it needs to be 4. Okay. So this is 3. So exactly one of these is shaded. I don't know which. Well, now I'm back to having no idea what to do, although I know there's an unshaded here and an unshaded here, so I guess all of these are shaded? Oh, this has to get out through here, okay. Where is... Well, because I don't know if this is, I know this is not a border, but I don't know if this is a 1 or a 3. I'm betting it's a 1 and this is gonna... Okay, but I know this is a 3. There's 2 more shadeds in here. I know they're not there. They're not both there. I know the unshadeds, but they're not both there, and they're not both there. They can't be... I think this is always unshaded. And this is always shaded. If this is 1... Oh, that breaks. So this can't be 1. There's either 1 or 2. Oh, but if it's 2, it touches a 2, so it is in fact a 1. Right, this... If this takes the... Right, there's always... Right, okay. Hey, Maddie, welcome. Alright, so it's... So there's 5 shadeds in here. Oh, and they can't all be out here. So this is shaded. That does that. Oh dear. Wait, 3 months? Was that... I assume that was before SudokuCon? Because SudokuCon was less than a month ago. Oh, wow. That's impressive. Okay, so... somehow have to resolve one of these 2. Oh. Oh wait, no, that does not... Right, I can't... Right, I cannot... This has to connect out either through here or here, so I can't take both of these. So, at least one of these, right, and 3 of these. So I need to... Oh, I see. There's no way to take 3 of these and still... Yeah, okay. So, it's... Okay. Whoa! Thanks for the GGs. Yes, let's have a dance. Alright, yeah, I do think that was 5 stars, but it was like actually 5 stars and not like 7 out of 5. Oh, here. Sorry, I forgot to pin it. Although I guess now that I'm done, I don't need to pin it anymore. Oh, what's different about the, Oh dear. Oh yeah, this solution's wrong. Yeah, I see where it's broken. Alright. Well, that was neat. Do I have another? It's getting late. I should probably call it there. I'll leave this for Monday. All right. I'll wrap it up there. Nah, just I got off to a bit of a late start today. Also, my stream yesterday went a bit longer than it should have, because I guess part of me just wants to go play more of Sandustry now, but oh, Jim the Eternal's doing Incident at Galley House. Alright, I'll send you over Jim's way. I'll be back on Saturday. I might start Dark Side Detective on Saturday. We'll see. Alright, and I will, see you around. And, yeah, thanks for joining me. And, bye!